And we're live. Welcome to tonight's webinar. I'm Christoph. I'm your host. Already also have the two panelists with me tonight, Chris Stevenson and Ádám Sándor. Welcome.
Thank you.
Hey, good evening.
Cool. So we'll probably wait for another 2 to 3 minutes before we get started because people tend to log in last minute. If you want, make yourself familiar with Demio, sorry. And there's a chat. Some of you already figured that out. Say hi. Hi, Michael. Hi, Goose. Hi, Alexander. Hey, Marius. Hey, Jeffrey. Hey, Alexander. Good to have you here. It's great to see a few familiar faces. Hey, Kostis. So maybe a few housekeeping rules. Most of you figured out where the chat is. There will also be a poll in a minute that we'd like you to answer, but I'll get to that in a minute. This meeting is being recorded, and we will share the recording afterwards in an email. We'll also share some useful links. I'll take notes while we go through whether we missed anything. And so you can get the recording and watch it afterwards. If you have questions during the discussion between Chris and Ádám, feel free to post them in the chat. I'll collect them. And then in the end, we'll have time for questions and answers. And I post them to Chris so that he can then forward them to Ádám. If there's any technical issues, also let us know in the chat. There's also Florian from our team available for clarifying any technical questions, problems with Demio. If you happen to have ideas for webinars, then also please let us know. We had some really good suggestions in the past from participants. So the question is, what's interesting for you as next topic? Also feel free to share.
So if somebody has a really good suggestion, we just do that now, right?
This is actually born out of a good suggestion. It's actually born from a blog post about GitOps that we created together with Ádám, where we looked at the upsides and the downsides of it. And that's what ended up in this webinar. Yeah, it's a good example. All right, and with that, I'd say we are now 3 minutes in. Let's get started. As I said, there'll be a recording for everybody that joined maybe a bit later. And let's start this with a poll. And I post the poll right now. So you should be able to see it. So what we want to know to kick this off is, are you using GitOps in your organization? There's 5 answers. Yes, we deploy everything via GitOps. Yes, for some services. Yeah, we're trying it out. No, we don't use GitOps at all. And what is GitOps? And I do already see answers coming in. Nice. So this will be a good starting point for the two of you, Chris and Ádám. So I'm happy to hand over to you, Chris. All the best, and I collect questions in the background.
Thank you very much, Christoph. So hello, everyone. My name is Chris. I am a CTO here at Humanitech. Humanitech is a company that builds your internal developer platform. And maybe we'll cover some of that later. But I'm very pleased to have Ádám Sándor here with me. Ádám, do you want to introduce yourself?
Sure. Hey, Chris. And hello, everybody else. I am an engineer who lives in Amsterdam, actually. I work for a company called Container Solutions, which is a cloud-native consultancy company. So we help other companies adopt cloud-native technology. And I came to the idea of GitOps about 2 years ago during a project we were doing with a German enterprise company. We tried it out, we liked it, it worked out pretty well, and ever since I'm really excited about this topic and exploring it. Just recently, I actually had, together with you guys, we wrote a blog post more focusing on the downsides. And that created quite some discussion, so I'm happy to talk about all these things again today.
Very good. So I can see the results of the poll coming in. It looks like maybe a third of our audience are in the not using GitOps at all or in the what is GitOps category. So maybe it's worth just spending a couple of minutes going over the basics of what GitOps is to make sure that everyone is on the same page before we dive into the details.
Sure. So yeah, we agreed we will do some drawing today. So let me fire up my Xcali draw here. There we go. Should make it a bit more easy to follow what we're talking about. So GitOps is the idea to basically drive your infrastructure based on Git. And it was born in Kubernetes land, basically, because Kubernetes is just so easy to configure with static configuration files and with a completely declarative configuration, which is really important for GitOps. So if I have my Kubernetes cluster here, and I have some things on it like a deployment and a service and whatever else I can have in my, and then of course a bunch of pods created by that. And there will be YAML files I'm using to create these things. So I'll just put my YAML files into a Git repo. And the rule of GitOps is, and by the way, it's a vague term, so some people would contest basically anything I say here about GitOps, but this is, I think, in my opinion, the best definition of it is that whatever I have in this Git repo, like I would have, let's say in this case, maybe a deployment YAML and the services YAML, whenever this changes in the Git repo, this immediately and automatically gets synced to my Kubernetes cluster. That means there is no extra manual process here between this Git repo and my Kubernetes cluster. This synchronization will happen mostly, but not necessarily, by an agent running on the Kubernetes cluster, which might be something like Argo CD or Flux CD. But it can also be just a Jenkins pipeline if you want it to be. So the important thing is that I'm driving my infrastructure, what's running on my Kubernetes cluster, fully from a Git repo. This is, I think, the concise description of GitOps. Does that make sense, Chris?
Yeah, I think it makes sense to me. Hopefully it makes sense to the people in the webinar as well. So this is obviously kind of on paper a great idea, and has obviously been implemented well across many companies, and many people are getting benefits from it. One of the things to think about, though, is every paradigm has its own limitations, and there are shortcomings with anything, and it's a question of making compromises between different advantages and disadvantages you have with the system. So what are the limitations that you've seen in implementing GitOps?
Right. So let me start with sharing my screen again. So limitations. If we look at this picture, well, while we're looking at one Git repo getting synced to one Kubernetes cluster, it's really, this works perfectly. Everybody can update this Git repo using pull requests, which is great. So basically, by the way, Weaveworks is originally behind the idea of GitOps, and they coined it as operations by pull request, basically. So I can like drive my infrastructure changes through pull request. Anybody can submit a pull request, somebody else will approve it, and that's when this gets synced to the cluster. One interesting part where GitOps bumps a bit into reality is that mostly you, like in a continuous delivery environment where you're deploying your applications all the time, you don't actually want to be creating pull requests against this Git repository and approving them, because that would mean that every single new version of your application that gets deployed has to go through a pull request process that is not changing this is not your source code repository, right? So your source code repository would live to the left of this, and this would be your source Git repo. So so you would have a pull request process here. You release your application, and from that point on, you pretty much want to get it deployed to some environment, not go through another pull request process here. So when you do that, and let's say there is going to be some kind of CI tool, and I'm just going to use Jenkins for CI tool. And there is going to be a pipeline that builds your, let's just call this straight away, the Jenkins pipeline that builds your Docker image. Now, after the Docker image is built and you want to deploy to a GitOps environment, it will mean that this Jenkins basically has to do the pull request creation and also merging it if you want to be fully automated. We want to have a fully automated deployment. And that means, and basically doing programmatic changes to Git is kind of awkward. You will have to do how we implemented this was that, well, first of all, just the naive implementation. Of course, you clone, you apply changes to text files, right? And update the version number in the deployment YAML, and then merge the pull request. We were using Bitbucket, so using Bitbucket's API, we merged the pull request. But there can be problems when another process is also writing to the same Git repo, because you will probably not have a single deployment and a single service and everything very simple. But once you have multiple Jenkins pipelines here, then suddenly the whole thing that basically Git is not a database. So like multiple processes dumbly writing to it will cause problems. And so we had to solve that with, basically we leveraged the fact that each of these processes were always writing to a different deployment YAML, because there was like one application and another application. We could do retries in this Jenkins pipeline because there was never a real conflict in these files. So we whenever a Jenkins pipeline failed to write into the Git repo, into the GitOps repo, then we just retried that. So that works, but it's not as pretty as the whole synchronization part on the right, and kind of starts to make you think whether we should have some kind of API here to the left of the Git repo that could just, manage these automated writes to Git in a nicer way. So yeah, that's where I would start. What would be your what would you like me to talk about? I know we went over a bunch of options we could raise here. So this is my favorite.
So I think the sort of programmatic update thing is interesting. There's also another element to that, which is obviously if you're updating these individual items in an automated fashion, tracking tags from your CI, the build part of your CI process through to the Git repository makes sense. But if you need to make other updates, I think there's programmatic updates. There's also this problem of validation of inputs, right? So you do risk the fact that some upstream person can make a change to the base, say, deployment YAML, which has an error in it, and that just gets blindly passed through your system, and you don't necessarily know until you get a deployment failing in your Kubernetes cluster.
Yeah, exactly. That's also an interesting point, because the fact that we are using Git here, basically Git becomes, in this GitOps setup, Git becomes the API towards the cluster. So which is awesome and terrible at the same time. So basically the whole idea of GitOps rests on the fact that none of these components that we are like basically mostly Git is at the centerpiece of GitOps, right? And Git is not designed to do this. We are in a way misusing it, but we are using it for the right stuff, because these YAML files are text files and they go perfectly in Git and they can be perfectly synced. So that's all good. But of course, Git will not do validation for us. Again, comes the question whether we should have an API here, because either an automated pipeline or a person just manually merging something into this Git repo will not be able to validate these files. Of course, we could set up we should set up test processes. So like this first thing should go to a development environment, and then later we should promote that to a production environment. But still, like it would be so much more elegant to catch any invalid YAML files or something before they would get merged. But in the GitOps setup, the only way to do that is either validation here in this pipeline or basically other places. And that also kind of shows that these problems we talk about here today are not unsolvable. It's rather that they can be solved in 5 different ways, and everybody's got to solve them in their own way. And we kind of talk about GitOps as if it's like this method to do things, but actually it's more like an idea, and then comes all the things that you need to solve yourself in different ways.
I think that point is actually very, very important. Something like GitOps has only really been a concept for maybe a couple of years, and there is no definitive solution to anything. Like it's still evolving. People are still figuring this out. Yeah. So I think that's something to really bear in mind. So one of the other things that I've heard people complaining about regarding GitOps is to do with visibility. And I think this lack of visibility about actually understanding what's happening stems from the elements you mentioned before. But I wonder if you had any thoughts around that.
Yeah, so the thing is, again, like Git gives you a great view on the history of all the changes if you have the time and everything to dig into it. So the beauty of GitOps is that, of course, every single change you make to your environment is recorded in Git history, which is a huge step forward for many organizations compared to how they do things before. Of course, by the way, I would just mention here a bit of a sidestep that storing Terraform files or CloudFormation files in Git and then syncing them to your cloud environment is also GitOps. So GitOps and infrastructure as code, there is not a big difference between that. I think a bit what's special about the GitOps, how we talk about it here, is that we're talking about deploying applications to Kubernetes with it, which means more frequent updates to Git repositories, more moving pieces, and so on. So it's in a way it's somewhat different. But yeah, so back to the visibility part. You don't let's say listing how often did a certain application change in your GitOps repo would require you to basically watch how often did a line of code change in your deployment YAML. So the beauty of GitOps is that you're storing text files, which means you can store anything in there. So you don't have to worry about, are we supporting this or that Kubernetes object? But on the other hand, you are working with text files, and that poses certain limitations on how easy it is to dig data out of that Git repo. A colleague of mine actually did a little project on exposing GitOps changes as Prometheus metrics to monitor your GitOps with Prometheus, which is an awesome idea. Unfortunately, we never had the time to really follow up on that, but I'd love to do that someday because it's kind of cool. Yeah, so that's I think about the observability. But of course, again, here are solutions. Like you can just watch the actual changes on your cluster, which you will do anyway, and visualize that rather than visualize what's in your GitOps repo. So it's there are options here to mitigate this.
So I think part of the question here around the lack of visibility and also the problem of programmatic updates, especially dealing with merge conflicts that will inevitably arise when you have multiple different processes trying to update the same thing. One of the ways that people come to solve this is say, well, actually, we can partition things a bit more. We can maybe create separate Git repositories. Maybe we want to create a Git repository per environment. Maybe we want to be managing different applications or different repositories, various other ways of dividing things up. So this kind of proliferation of Git repositories to solve these kind of problems. Is that something that actually happens in practice, or is this just a whiteboard exercise?
Yeah, no, we ran into that big time. So how we implemented GitOps, let me show you here, is so on this picture, let's say now we have one single Git repo, right? So let's map that. What we did was map a single Git repo to a single environment. And by environment, we called the environment one team's one like continuous delivery stage. So let's say this would be a namespace here that is, let's say, team X's dev namespace. And then, of course, Team X would have other environments. And other teams would have all these environments. So Team X would also have prod. And then Team Y would have also dev and prod and staging and all these things. So, and that actually over multiple Kubernetes clusters. So I'll get rid of Jenkins pipeline from here. So, and then you can do different things. You can, for example, put one team's all the YAMLs for different environments for a single team. Let's say this would be the GitOps repo of team X. In that case, you would have maybe directories in this Git repo for each different environment. The upside is, of course, that you can like do all kinds of templating magic, like that. What the stuff that is similar between the two environments you could keep in like one directory and then just customize maybe to modify them to based on the requirements of different environments. The downside why we didn't go with that is that then you can't have granular access control to who can do what to each environment. So basically, our use case was why we did use GitOps was what gave us the most inspiration to use GitOps was the fact that it was a very audit and compliance and security sensitive environment, financial sector. So that meant that we were very happy that for our production environment, so our development environment would go like this. Jenkins pipeline creates pull request and actually merges pull request into the development GitOps repo. So this would be the GitOps repo of Team X dev environment. And then there would be a GitOps repo for Team X production environment. And in our case, to production, only approved personnel could create pull requests for production, and they would actually do that. Like actually, the Jenkins pipeline would create the pull request, but only the operations people could merge the pull request. So this was very important for us, and that led to separating these repos. And separating the repos also helps with avoid conflicts, at least some of them, because we did still have conflicts. But then what we ended up with, so this was an environment with about 50, 60, 70 teams, each of them having 4, 5, 6 environments, because some of them had production environments on different clusters. And then we had a lot of Git repos to manage. So that was also something unexpected we ran into. And that amount of Git repos posed a bit of a headache for operations also, because like Git, like for example, Bitbucket's interface for managing pull requests is pretty good. It's very nice way to do things, but suddenly they had to manage like a ton of pull requests for a ton of repositories, and that became much less user friendly, and you can't really like improve the UI of Bitbucket because it's a tool that just works as it works. So yeah, so this proliferation of Git repositories is a risk, because and whatever you do, you try to bring everything into one repo, use customize Helm, whatever, to like to do nice magic on the files, or separate them out. Both have upsides and downsides. So be prepared that Git repository management if you have a more complex environment, then Git repository management is going to be a thing.
I can imagine that actually the proliferation of Git repositories also has an impact on that lack of visibility we were talking about earlier. Because now not only are you trying to piece together from a single Git repository exactly which deployment was updated at what point, but then you need to cross-reference that across multiple Git repositories which are independent of each other.
Yeah. So let's say to answer a question, how the hell did this image end up in production? To answer that question, you would have to go into the history of the production Git repo, and then to the staging Git repo, and then to the development Git repo to see how some image progressed through all those Git repos. Yeah.
Yeah. So I think we can see this kind of issue with the proliferation, and I think, as you said, there's multiple strategies to solving this. I think that's important to underline. That the solution isn't necessarily more Git repositories, but if you don't use more Git repositories, then you have other problems. So it's always about this compromise and choosing which one works for your particular use case, and basically trying it out, I guess. So one other area which I find is actually kind of interesting is using a GitOps approach is seen as being very kind of modern approach, very taking advantage of this kind of declarative structure and so on, but it does not give you any kind of out-of-the-box ability to do more kind of fine-grained process control. So I'm thinking about if you want to do something sophisticated like a canary deployment, then it's kind of hard to declaratively put that into a GitOps flow. I wonder if...
Let me just... show a good example of that, how that is a bit of a problem. So basically, we assume this synchronization here happens like really fast, right? So YAML file changes, and the write basically by, let's say, Argo CD or Flux CD, the write to the Kubernetes API server happens quick. And then this reconciliation here happens that the deployment will actually be updated to the image that's in the Git repo. So already, when you're just using Kubernetes deployments, this process might actually take some time, and it might actually fail. And basically, in GitOps, there is not much you can do about that. Argo CD will tell you that your deployment has failed, but then again, for that's a bit of a problem, because developers are sitting here inside their Jenkins or Circle CI or GitLab or whatever, and Argo CD is sitting over here. So even if you have no security or other problems giving everybody access to Argo CD, it already is an extra UI somebody has to navigate to. And so that's when this deployment is happening. But that deployment is still happening pretty quickly. So like maybe you can go take a peek at Argo CD in 5 minutes and see if everything is all right. And of course, you can hook up Argo CD to Slack. So there are ways again that there are things you can do about this. But let's say you want to do, like, the deployment as a rolling upgrade, right? Let's say you want to do a canary rollout. And in that case, your rollout, let's say you would have in that case probably 2 deployments. So one with the old version, one with, okay, I'll just delete services from here now. So you would have old deployment and new deployment. And then you would maybe use Istio to route 1% of the traffic to the new deployment. And then you start increasing this percentage, right? And this might take several hours until it all goes through, even if nothing breaks. So, and basically all you will see in your Git repo is that you said you want the new version, and yeah, the new version is there, but it's at 1%, and there is no way really to reflect that in this Git repo. So this Git repo just basically becomes an obsolete view of a state you wish would happen on the cluster, but it's not what's really there. So you can never 100% trust this Git repo that this is what is actually in production. And that also means that the whole auditing thing that comes with this Git repo becomes a little bit questionable. If there would be a really hard audit question, let's say in case the cluster, like some application got hacked and you really need to know like which version was running at the moment, then looking at the Git repo, you only know which version you wanted to run at that moment, but not exactly what actually happened on the cluster. And yeah, there are again strategies to mitigate this, like you don't just trust your Git repo, but you also have an audit log of what happened on the cluster, or alternatively, you could write back a certain state into the Git repo to update it with like maybe at the moment that it really fails, then maybe you could write back. I've never seen that done, and I'm not really sure if it's a good or bad idea. Sounds a bit fishy, but maybe it could work.
Thank you very much. I think that's definitely an interesting point that you'll come to with larger scale. So I've seen that a huge number of questions have been coming in on the chat while we've been talking. So I think it might be a good idea to pivot to answer some of these questions that come in. So Christoph has been doing a good job of trying to kind of categorize them a bit. There are a lot of questions which are covering various things on environments. So I kind of summarizing them together. The questions are, how do you manage the configuration between different environments? I think you touched on this with using separate repositories, but it might just be worth covering kind of the directory approach, possibly even branch approach or separate Git repository approach to try and manage multiple environments.
Yeah. Let's do that. Let me jump back. Okay, so I'll try to stay with this picture because we all like a bit got used to it, but it's also getting a bit crowded. Right. So basically, I would focus on the problem of promotion because that's really the interesting part. Because of course we can have different environments backed by different Git repos and just synced. That's pretty straightforward. But what happens when this deployment YAML? I will just make this a bit bigger. Yeah. So this deployment YAML. Maybe let's just really make everything like normal font, even though I really like this hand-drawn one, but it's not that easy to read, I must admit. This deployment YAML we would deploy to the dev environment like version 1.0, and on our production environment we have 0.9 running. And so how do I get 1.0 over to here? And first of all, let's take a look at our approach of like having a different Git repo for each environment. So what we did, how we got this 1.0 over to here, was that the source repo actually contained deployment YAML, but with version X. So basically needs to be templated, right? And there was a Jenkins pipeline. I will delete this other one here. And this Jenkins pipeline basically didn't just deploy to a single environment, but we had a long pipeline. And this pipeline deployed to each environment. And for each environment, it inserted 1.0 into the deployment YAML and overwrote and created a pull request to override the deployment YAML here. And once people were happy with the dev environment, they could push a button in Jenkins, and basically Jenkins would do the writing of another similar deployment YAML into the production environment and upgrade it to 1.0. So basically, we had a pipeline that knew that we want to eventually get all environments to 1.0. So let's walk over each of them and update them in sequence when like the tests are done and so on. This is one way to do it. Another completely different way would be to have, let's say, just a Team X Git repo, Team X all environments GitOps repo. And inside this repo, we would have maybe a common, or just maybe let's make it a common directory where we have a deployment YAML, and then we would have a directory for dev, where we would have just I haven't used customize, I know it, but I'm like, so I might be writing something stupid here, but the point will be made. So a customization YAML, I think, that would have like 1.0 in it, and then prod would have customization YAML 0.9 in it. So basically, and then I would run customize to template deployment YAML with 1.0 and 0.9, and update environments based on this single repo. So again, this is a completely different way, and basically this would always be a pull request on the same repo, just changing. Maybe this would be a one-liner that only has the version inside it, and then I can change it, and basically by that keep promoting the image over the different environments. So these are the two ways I know, and I could imagine doing it in many different ways additionally to this. But this is how you can manage different environments. And I think this is the most popular way, because unless you have those security constraints like we had, that you really need different security credentials and access to production environment and to development, this way you can nicely manage that you don't have copies of deployment YAML lying around like we had, because this was a complete copy of the deployment YAML over here. So yeah, this is definitely more elegant.
Yep, so thanks for that. And looking at the questions, I think we maybe even answered an additional one about whether it's possible to have a GitOps style with just one repo. And so the answer is yes, you can. And there's also a comment here about having different GitOps repos per environment, leading to divergent state. But I think the point you made there is around like the security partitioning is the flip side of that. So it's always you compromise somewhere.
Exactly. And by the way, we didn't have much problem keeping environments in sync. So it's also one way to do GitOps is that you just manage different environments with tags. So basically you have that image like I had with the different directories, and then you keep moving tags in the Git repo. So that would mean that at some point already all the the production environment will have to catch up with the development environment. You can't have divergence. And actually, when we started building this CI/CD system, we were afraid of these kind of constraints. We were not sure if we will not have to diverge between the environments. I think in the end we did not really diverge, but yeah, we didn't want to put that constraint on ourselves. And in the end, we kept the environments in sync by always writing to them from the Jenkins pipeline, and that worked too.
Yeah, I think here one of the important things is to really understand the structure of your application and really define what is environment specific and what is not environment specific. As long as you can make that decision and that distinction, then diversion shouldn't be too much of a problem. Where you start putting some non-environment specific stuff in the environment specific stuff, or vice versa, that's when diversion is going to happen.
Exactly, yeah, that's a good point. And also there is natural diversion, so we will have some extra services in production running that you don't have in development. But even with the multi-directory customized thing, you can handle that. So
yeah, I think the classic thing, just to kind of make sure everyone's on the same page here, is the database you're connecting to. If you're connecting to a database in dev and a different database in production, you want to make sure that you don't accidentally promote the dev database to production, because then you potentially end up with your production infrastructure trying to talk to a dev database, which is not going to make anyone's day.
Yes.
Cool. We have a load of other questions. One here, which I think is kind of interesting, is I've lost it for a second. So using the concept of submodules within a central repo, or trying to manage multiple teams within the same repo. So I guess that's taking your single team idea with multiple environments and then saying, well, actually you have multiple teams in the repo with multiple environments nested inside those. What are your thoughts on that kind of approach?
Honestly, no idea. I don't know what would that lead to, what would be the advantage of it, and what would be the disadvantages. I've never used sub repos in Anger like for real, so I can't foresee how would that affect things.
Yeah,
Windows, by the way, I see there two customize questions there, and to those I can also say I'm no expert on customize. My colleagues are doing a GitOps setup with a client of ours where they are doing the thing that I showed there with the different directories and the customization files. But I can't tell you more details because I'm not working on that. I was just like watching a presentation from them on how they're doing that. And yeah, sorry.
I think with all of these things, in my experience, as you flex the paradigm a bit, you end up kind of falling down holes. And I think Customize is a great tool, but it can lead you to awkward situations. I think the effectively their version of the fragile base class problem, for those of you who are object-oriented people, is a common complaint of Customize, for example.
Yeah, I can imagine that. And but then there is a completely different approach where you say that only final YAML files can go into the Git repo, right? Where any kind of Helm customization, whatever would happen outside, and the Git repo has to reflect like the final prepared Kubernetes YAMLs, and that makes sense too. Because then really your repo, there is no more magic happening on the repo. It's exactly shows what the environment should be. But then again, it's a completely different way to do things than with Customize.
Yeah, I guess the interesting there is then how can you validate differences between environments? So if you take the structure away from like a Helm template or customized definitions, then actually understanding what the material differences between environments becomes very, very difficult because there's so much noise with kind of general extra kind of verbosity of YAML files.
Yeah, and I see now Alexander asking that he didn't hear the bad and the ugly. So I think that was that's a good point. Like I was talking maybe a bit too lightly about things, but what I meant by the bad and ugly is like all the topics basically were basically the bad and ugly. The Git repo proliferation, the programmatic rights to the Git repos, the fact that the auditing is not so amazing as it looks on first sight. So this is the and this is what's in the blog post too that I think we'll be sharing after the session. So these are not things that are like actually that blog post generated quite some negative comments because people were reading it like, oh, you're saying GitOps is bad and whatever, and that's not really the point. The point is rather that it has its limitations, and that's I think today's takeaway really, and that you will have to. There are solutions, but you'll have to work them out for yourself. What will work and what doesn't, and there is no like a straight path that's clearly laid out.
Yeah, I think in terms of this this kind of topic area, it's the same as everything else. There is a new technology that comes in, everyone gets really excited about it, a new approach, everyone is like, oh, this is the best thing ever. And at some point, people will discover the limitations of it. It doesn't mean you should stop using the approach. I mean, people haven't stopped using object-oriented programming because of the brittle base class problem, right? They've said, well, actually, the advantages are such that I can make use of it, but maybe I won't use it in all cases, or maybe I will bend the rules a bit so that I can actually achieve what I want to do. And it's the same here in GitOps, right? It's a series of techniques and a philosophy. But when it hits the real world, you're going to have to make compromises. You're going to have to work out what is important for you and your team in order to figure out whether it's a fit for you.
There is only one thing you should never do. and let's put a manual process between the GitOps repo and your environment, because that's what really breaks the whole idea. It looks like a small thing. Oh, after the Git repo changed, I just want to still push a button because I'm afraid production is going to change it, whatever. But that like really breaks the idea, because then your Git repo is detached from your environment. If nobody ever pushed the button, then it's like then it's not never happening. So that's the only thing I really don't like to see if people say they do GitOps.
Yeah, I'd just say Brian has asked, is the PR approval not a manual process? But
yes, but yeah.
Go ahead. Yeah.
But that happens before the merge to the Git repo. So after the PR has been merged, at that moment it's getting synced, even if it's whatever happens.
Yep. So we've also got a couple of questions. I said one of them is, at this point, would you still recommend GitOps versus scripts calling kubectl? I would say that probably having a process that is systematized is always better than just running freehand kubectl commands. Even with the negative sides we're talking about, I think you get a lot of net positive. So, for example, having the Git history, even though it's really hard to parse, is better than having no history. So if you're just running free-form kubectl commands against your cluster, then you have no idea what happened. Whereas at least with the Git repository, you can spend a couple of hours figuring out from all of the commits what actually happened. So it does give you some information. So it is still a positive, even though it's not the kind of necessarily the golden sunny uplands we were all expecting.
Yeah.
And just a follow-up question to that is also, is there a particular tool or paradigm you recommend looking into? So obviously, I think GitOps is an established tool or paradigm here. I think the general idea of having a systematized way of moving things into your cluster is probably the kind of, if we step back, the philosophical thing that makes the most sense here.
Absolutely.
GitOps being an implementation. Do you want to add some thoughts to Adam?
Yeah, I think that's actually, when we started off, we didn't even realize this, but those GitOps repos basically became an API towards their own environments for developers, where they could modify their environments, where they could see the history of what happened to their environment and so on. And that had a really good effect that kind of made the CI/CD system into a platform with a clear delineation between like whatever happens left of the GitOps repos, we were helping developers with. So that long Jenkins pipeline and stuff, we were helping them with, but it was still their responsibility. And all the security and compliance and everything that our responsibility was to make sure that happens was on the right side of the GitOps repos and with the pull requests. So a bit on the left with the pull requests approval to production. But there was this clear line that what's the API towards deploying applications.
Yeah, I think there's the kind of generalized term of this is kind of an internal developer platform, and effectively GitOps can be your internal developer platform if you wish. And in fact, you see a lot of companies have adopted elements of GitOps and combined it with their own in-house tooling to deal with some of the edge cases we've talked about in order to make sure that they have systems that work for their particular needs in their particular scenarios.
Exactly. Yeah. GitOps is nice, like nice in pushing people to think in terms of really a developer platform, not just like a script and stuff supplied to developers that they can then use to do things. And where I would recommend GitOps really is so like in big complex setups like ours, that's where all these problems come out. But for smaller, simpler setups, it's awesome. It's just it gives you so much for cheap, basically. For just everybody has Git, everybody can sync, they can set up a Flux or Argo CD, and it just works, and it puts you in a much better place. With even though you down the line you will have to solve certain things, and maybe you would at some point some scale or some away from it or some complexity, but it is a very solid approach. That's why it's so popular, obviously.
So there's another question which I see a few people are referencing. which I guess we haven't touched on. We've neatly skirted around it, and that is the secrets question. How does secrets work in a GitOps world?
Yeah, so the two major answers to that is, one, you just completely avoid the question and basically manage secrets in a different way. Let me just quickly bring back one last time the Excalibur. So you can have something like HashiCorp Vault or any of the secret management KMS solutions of cloud providers, and basically either so that would be your pod, right? So your pod running that the deployment created. The pod could like just load secrets using the Vault API, or there could be some operator that puts the secret from Vault into the cluster. That's one way. So basically avoiding secrets and GitOps, mixing secrets with GitOps. It's a bit awkward, right? Because you want to have everything in GitOps and then the secrets are coming from another place. There is a nice new solution to actually putting secrets into, like managing them properly with GitOps. It's called sealed secrets. So sealed secrets works with an operator that you put into your cluster, and it's called the sealed secret operator. And sealed secrets, what it will do is you will encrypt your secrets and put them into Git. So your Git repo will contain something like encrypted secret.yaml. Of course, it doesn't have to be a separate YAML. This will create a sealed secret object on Kubernetes, like this one here. Like this would be the final secret, but before that you would have a sealed secret here. And I really like this approach. And you would have a sealed secret here, and then this operator turns the sealed secret, unseals it, basically unencrypts it or decrypts it, and creates a secret from that. So the sealed secret approach would nicely help you, like keep the GitOps flow and use that for secrets. On the other hand, the Vault approach also has upsides because it just provides a nicer UI and everything for managing secrets. So again, ups and downs.
Yeah, I guess with the sealed secret approach, you also have the problem of kind of secret proliferation, especially if you are proliferating your Git repositories. You end up with secrets spread all over the place, and keeping track of those from an audit perspective is tricky.
Yeah, and like enterprise security departments or auditors don't like to have a system where the secrets are kept and where it's all recorded, who changed what when, just for the sensitive stuff, and not having to go through a Git repo history to find out.
Very good.
So
I see Christoph has turned up, which really means we're running out of time.
It's true. That is true. I know there's a lot of questions left. Hope we have a chance to cover those after sending out the summary of this webinar, maybe in one form or the other.
But really good questions. Great audience. I think I would love to talk about a few more topics in there. It's just too much time today.
And for a part 2 then, Adam, at some point in time. Cool. So thank you so much to both of you, Chris and Adam. It's really great to have you. Thanks for everybody in the audience for participating. And as I said at the beginning, we'll share recording. And we got a proposal for part 2, all possible implementations of GitOps, a list. Okay, thanks for your recommendations. Keep them coming. You can also send an answer to the email that we are going to send out tomorrow morning with the recording. Feel free to do so. And Adam and Chris, we sit down together and think of a part 2 of this. Thanks. Have a great evening.
Yeah, thank you guys for having me. It was great.
Thanks. It was great to chat to you.
Bye.
Bye.